value to this variable, you can just come here, just like we applied this sum function. Instead of you writing all this long thing, you just put the numbers, since it's not the same thing as numbers. So you just run numbers, and then it also gives us that for 55 we saw here too. And then we can decide to check for the average, which is the mean. The function we use for checking average in R is mean. And we'll click here. So the mean value of these 10 numbers here is 5.5. So you can see how beautiful R can be, making life easy for data analysis. So let's continue with checking the length of characters. But before we go there, let me come back to the. Okay, I don't know. Are you following? Is everyone following? You can just put a thumb up.
Yeah, following.
All right, fine. So let me switch it back again.
There is a little question I have.
Okay.
Okay, now, can you go back to the code?
All right. Okay.
I know some persons might have this question as well, but there are people like me that always want to stay behind the behind. You know, when you put in the sum function, there is a bracket that comes up, and then there is something like a C before the next bracket. What is it part of the code?
Okay, that is here, right?
Yeah, exactly. That's
yes, it's part of the code. So what we're trying to do is, you know, we have 10 numbers here. You understand? So we're trying to call 1, 2, 3, 4, 5, 6 down to 10. We're calling number 1 to 10. So we want to call this group of 10 numbers, and then we're taking them together. They're not separate. We're taking them together. So for you to put them together, you need to apply. That's why I described this first one here. You need to apply this C function. This C function means like grouping it together as one. You understand? Okay. Like we don't, because if you don't apply this, it's just like saying, okay, you want to start typing 1 plus down to. You understand? So why I applied it this way is because in a situation where we want to, that's why when we get to this place where we assign these numbers, it's easier for us. Because if I start putting 1 plus 2 plus 3 plus 4, it's just going to attribute the sum for us. But we cannot take that particular line of code and say we want to assign it, like, and use it here. It might bring out an error for us. So it's like this. So when you group it this way, you can decide to apply the sum function. So it's always if you want to run a function on a particular code, it's always good to have the function as the first thing. So we're not putting that sum function inside the C. So we're like applying that group of values and putting it inside the function. So this is where the coding thing gets interesting and a little bit confusing anyways. So, but with time you get to understand. So this is just a simplified way of understanding it. But do you understand what I'm trying to say?
Yeah. I got that now.
Okay. So it's just the C function is just to group it together. And then as time goes, you want to actually assign variables. You can just take it together and assign it together. So now, I think we are at the length of character. So there's a function called length. We want to know the length of a particular character. For example, this is Alex. So if I just highlight this Alex now and run Alex, is on the console showing us Alex. And keep in mind, if we are always trying to run a particular character variable or any character variable, it always goes with two hyphen at the end. It always go with two apostrophe here, which is the first one and the last one at the side, which are very important, which actually signifies their characters. So without these two commas up here, without this indentation up here, and you just run it that way, it might bring out something. See, they say object Alex not found. So anytime you're applying a text or a character, you need to apply those two things for the computer to read it. So R doesn't understand that code, Alex. So you need to apply those two. And then let's go to the next. So this is the same thing we applied for these numbers, names. So we're assigning Alex to just a value called name, to just a variable called name. So the value Alex to just a variable called name. So let's apply another one, a group of name, Mike, Alex, Jane, and Anne. So we group them together and give it names. So if we run this, so we see them here. Mike, Alex, Jane, and Anne. So these are 4 names here. So let's check the length. Want to get meaningful insights. You cannot just look for any particular data analyst and then tell him, oh yeah, start analyzing the data in my company. The person might not understand what is happening there. You need to get to know how to understand the data that is generated there. So first of all, you need to employ the person. So this employment strategy is what we use here for installing. So we employ the person, that is like install the package first. So after installing the package, and then you now, after employing the analyst, you now call him and tell him, okay, I now want you to help us analyze so amount of data. So this is where we now use the library function. So the library function is like loading that particular data set we actually installed, particular package we installed. So we have to now load it. So to load it, we use the library function. This time, not the install package function. We use the library function to load. So for us to load, you just you can put your cursor here, but it's always fine to put it after the code. And then you can click run, or you use Control Enter. So when we run this, it's showing us it has loaded, it's attaching the packages and the rest, so it has loaded it successfully. So we'll load this one too, which is successfully loaded. So let's go. No error was, see, if there's an error, it will bring out something written in red form like this error or something. So everything is perfect. So now, let's see how we can import data. Okay, let me clean this so that we get. So let's see how we can import data. Importing data with read Excel and read R from the tidyverse. So you see, R can handle various data formats. The most common format is CSV. So this is the code we use to import CSV data or even Excel data. So it's a simple code. First of all, you read, there's a code called read_CSV, which is a tidyverse function. The tidyverse function. So let me show you why I say the tidyverse function. So let me type it. You see read_C. So you can see it. Read_CSV is in read R, and this read R, as I told you, this tidyverse has over 8 to 6 packages. So this read R is a package inside the tidyverse. So this is the tidyverse package. This function is from the tidyverse package, and that's why we loaded the library for us to use this function. So always remember, most of the functions that comes from the tidyverse, you need to actually load the library before using them. Okay. So you read_CSV, and then there's a code inside we need to follow. So the path is showing us, okay, where is the path? Where is this particular data? Where will it be coming from? So you first of all there's a hard computer. After the hard disk, inside the hard disk, you have the user. After that, we have a particular folder called your computer. You are using HP, Apple, or I don't know how it's actually programmed on the MARC, but on the Windows computer, I'm actually using a Dell computer. So it's C, users, Dell, desktop, and then this is the folder I have, the data sets, and finally the data sets. So this is just it here. So let's read the Excel file. So I'll show you how the Excel file look like now. So there's an Excel file called time used. So first of all, you just follow what is happening here. So we have C, we apply that column, use the black slash, and then we'll write user, we'll follow it, another backslash for the del, the next one for the desktop, next one for the R, and then down to the data sets. So this R, that is intro to R overview. So this is a folder. There's a folder here in my computer. You can see the folder, intro to R overview. So that's why I'm seeing it there, programmed that way. So that's why you see it after my desktop. Then you see the intro. Some people might decide to have the file in their documents. So it will be documents and then the file. So it depends on where you keep the particular data set. And then if you run this particular line of code, remember we're trying to remember what I talked about assigning values. So we want to read this particular Excel data and then assign it to a particular object called Excel data. So we actually know that it's Excel data, just for clarity's sake. So if we run this code, you can see it. Remember I told you here is where we see our data sets. So now you can look at it here. You can click the arrow to check the structure of your data set, but if you don't want to see it and it's confusing you, you can just click on the Excel data itself. So when we click on it, it populates here and then it's showing us what this data is all about. So here you can see it has 494 observations and 13 variables, which is 494 rows and 13 columns. Okay, so let's go back. So now we have imported an Excel file. We want to import a CSV file. So I shared this file, this NHANAS file from the National Health and Nutrition Examination Survey. So it's just a subset data from the main actual data. I just extracted it for this introduction. So we'll apply the same line of code we did for this, but at the end we're now using XLSX. At the end, CSV. Now, if you want to know how your code, where your data or the kind of data set you have, a good way to know is when you click here, right click, go to properties. It's a type of file. See, this is a CSV file. You can know. Then you want to check this one. Which kind of file is this? Which kind of data set? You can check. You see, it's XLSX. So this is an Excel file. So this is a good way to know which particular file you have. Or if it's going to take your time, you can come down here to the folder where you see your file section. You can come here and check. You can see it's XLSX. And then for the other one, CSV. So this is it. So let's load this now. And we have assigned it, so it's perfectly loaded. So I have assigned it to a particular name called data. So this particular data set has 3,842 observations and 9 variables. So you can see how fast it loaded it. So that's why R is a programming language for running data analysis. Not just simple data analysis, even complex data analysis. And we can use it to actually manipulate thousands of rows of data. But if you say you want to apply this particular data rows of 3,842 or even more in Excel, you might see your computer hanging or your Excel malfunctioning. So that's why we use certificated softwares like Python or R for running data analysis. Okay. So this is it. This is a simple way of loading your data sets just by following that. Another way is by creating a project. So I'm already running a project here. That's another way of actually loading your data. So I'll uncomment this. So you can see here, I didn't even care to put all those line of codes because I'm already running a project. I created a project particularly for this particular report or code. So it has already picked it up. What it just did, since I created a project, it sent what they call a directory showing that particular folder where you're actually carrying out your code. So it's already programmed it and arranged everything. So what you just need to put is just that particular data set and your .csv or the particular Excel data set and then .xlx. So that's it. But for you to run this code and for you to run properly on your computer, you need to be running a project. I will not talk on the project now, but when we enter into the main R programming course, we'll tell you how you can create projects and run it to make your code easier. So if you see it runs and it's the same thing here. You know why it didn't show here? It's because of we have the same object here. We have data here and we have data here. So it automatically overwrites this particular one. But if I decide to put something here, and let's say data 2, and we'll run it now, you can see it shows here now, data 2. But what's the need of having the same data sets? So there is no need. So I'll just remove the data 2. I don't need the data 2. Okay. All right. So now we want to take a view of our data sets. You can come here to click on it and just view it. You can just view it by coming here to take a look. So here you have seen serial number, we have insomnia, we have the health rating, we have BMI, pulse rate, total cholesterol, physical activity, smoke, and then diastolic blood pressure. But if you don't want to start, there's a code you can just type. You also want to check the first few rows, you can just type head and then data. That is this particular data. Remember, just like I talked about here, once you assign variables, you don't need to start inputting all this line of code again. You just use this assignment and then keep on running the functions you want to run. You start taking all this plenty thing and putting it here. I'll just take my data. Since I've assigned it here, I'll just type data. There is head in brackets. You put your data and then you run it. You can see. So you see that particular line of code. Remember, here is for the output, as I told you. So you see that particular line of code, the output. This is the output we are seeing. And we also have it here if you want to take a full view. But we have thousands of rows here. You don't want to start scrolling and scrolling. So you can just take a view and know, okay, if it actually works. So now we have a table of 9 variables or 9 columns. So to check the dimension in the sense, you want to know how many rows or columns. This one there's no need of checking this. Since here we already have it here. It's already showing us 3,842 observations and 9 variables. But if you just want to know how to check it using code, there's a particular function called nrow. So we click on nrow. So you see, so it's telling us that we have 3,842 rows, which is the same thing we see here. So now I don't know if you're coming to understand why I said as was for you, but with time you get to understand that R has one of the best interface. Like, you are seeing everything you want at one piece. You just want you to come to understand how to use it. Before you know it, like, it's just the best you want to use for running your analysis. So we can click on the end code. It's still showing us that same 9 we see here. So now we're justified and satisfied that yes, we have 9 variables and 3,842 observations. Okay. So now let us do a simple descriptive summary using the summary function. So we can just check, let us see what we have in this our data sets. We can use the function, but this function spec is from the tidyverse. It's a function from the tidyverse. It's not a base R. Like this nrow now is a base R function. So let us type this nrow. So it's what I'm talking about. So you see the rows base. So it's a base R function. You don't need to import to use this function. You can use it in any data sets. Actually, R has some data set that comes with it. Something like empty cars data set. There's some kind of data set that comes pre-installed in R. So you can see with this simple base R function, you can just check. But this particular one, spec, is a tidyverse function. So it's a good way to check the structure of your data. So we can see. So we have 9 variables. So the first one is serial number. Serial number is showing us code double. So it's kind of showing us that this is a number format. The next one is a character format. The head rating is a character format. And then you can confirm that here. You can see character. You can see here numbers, character, numbers. So all those things are matching. And then if you want to just do a simple summary descriptive analysis of, like, you want to just see what is happening in your data, just to summarize this and check, just to get a brief insight, you can use the summary function and type on and then input the data in brackets. So when you click here, check your console, we are seeing it. So this serial number now is giving us a breakdown of the mean, quartile, the first quartile, median, the mean, that is the average, the third quartile, and then the marks. But remember that this serial number, we don't need to start having summary statistics on this. R is the programming language, so it should just give you what it should give you. But you as an analyst or the scientist, you need to understand your data. That's why they say data understanding is very important when you're analyzing data. You need to understand your data before you even start analyzing it. So this is a serial number. We don't need to start analyzing serial numbers. So the next one is insomnia. The insomnia data set, insomnia variable is a character variable. So you see that R didn't actually compute any analysis on it because it cannot start computing character variables. It's not built for computing character variables with just running simple summary line. You have to go a little bit deep to understand character variables. We'll get to that. So, but for that of BMI, pulse rate, total cholesterol value, you can see all those things are numeric, and all of them are continuous variables. So you can see it's actually giving us a breakdown of what is happening. So you can see the average BMI in this data set is 27.87, which is a normal, I think is within the normal range. Yeah, so the average pulse we have here is 72.3. So you can simple brief summary statistics you can get just by running just one line of code. So now let's go to a little bit of data manipulation. In this place, we're going to summarize character variables. So we'll use the insomnia and the health rating categorical variables. Remember, we have 9 variables here. So we have the insomnia and the health rating. So we just want to look at these two and see what is happening in these two. Since we couldn't see it from the summary function, so let's see what is happening here. So we use the distinct function on this to understand what is happening, and this distinct function is diverse. So for distinct function, we need to call on the data. So we'll type the distinct. After typing the distinct, we'll call on the data. Which particular data? Remember, we have 2 data here. And remember, you can load hundreds of data here. So I will want you to actually specify which particular data do you want me to analyze this particular code you're about to write on. So you need to call on that data. So we're calling on this data. We're not working with the Excel data, which is the time use data. We're talking on the NaH data. So we'll call on the data, and the name of the data is data. We'll just call it data, just for easy understanding. And then after calling on data, then you now say, now tell me the distinct variable, or tell me the distinct characters in the insomnia column. So that is it. So when you run this, it's telling us that there are 2 distinct characters, which is yes and no. And if you take a look at this with a bird eye view, you can see it's yes and no we are seeing here. So you can apply the same thing too for the health rating. So let me clean this column and type health underscore rating. R is case sensitive, so be very careful when you're typing, you don't make mistakes. This is health rating. So if we run this, so it gives us, there are 5 distinct characters. We have good, so some people are with good health, some people have a very good health, some people have fair health, some people have health, and then there's a poor health group. So there are 5 groups. The first one had only 2 groups, those that had insomnia and those that didn't have insomnia. So this one has 5 groups, those with good, very good, fair, excellent, and poor health. So now you can see we have now understood what is happening just by using the distinct function, because when we actually ran it here, we didn't understand what was happening here. Remember, we didn't understand what was happening here. We just saw character, but it was giving us breakdown for continuous variable, which was fine, but we didn't understand what was happening because here we are character variable. So that's why we applied the distinct function. So now we can't, not only can we apply it on the insomnia or health rating, we can also apply it on something like the smoke or the physical active variable, because they are character variables. So I just use these 2 for example. So let's go to the next. Tabulate a categorical variable. So let's use this one called physical active. So those that are physical active and those that are not physical active. So let's check. So we can use the count function, just like how we use the distinct function. We call on the data. So after calling on the data, we use the comma and then say this particular variable we want to actually tabulate is the physical variable or the column. So if you run this, you can see it has divided it for us. So there are 2 groups, those that are physically active and those that are not physically active. So we have those that are not physically active, this is no, and those that are physically active, this has yes. So 1,844 people were not physically active. Why 1,998 were physically active? So now with this count function, we now have an insight of what is happening in this physical active data. We can decide to also use the same thing for the health rating variable. So if we run this, you can see, remember when we tabulated this distinct, it gives us the distinct character, but it didn't count to tell us how many of them. So the count function is not just grouping it, at the same time it's giving us the count. So you can see them down here. Now this is why I'm telling you the console is where our outputs are given for scripts. So gradually you come to understand this as time goes. So next, let's select columns. Remember we are on data manipulation, and there's a particular this thing with dplyr. This dplyr is a particular library we use in tidyverse. So when we load the tidyverse package automatically, it has this dplyr, because the tidyverse has more than 6 packages or so, as I said before. So it's a particular package found inside the tidyverse. So if you load the tidyverse, it just helps you with other packages. One of very, very important package in our tidyverse. You can Google it, or you can check it later. So now we want to actually select a particular column. Yeah.
These distinct, and some persons are curious to know, is it the same thing? Does it serve the same purpose that distinct and count serve in Excel?
Okay, distinct and count serve in Excel?
Yeah.
Yes, to some extent, yes. But I think the way Excel is being formatted will not be the same way R is formatted. But they actually have the same plans of bringing out the same results. But it's just the syntax how is actually that might differ. You understand? Okay. So now we go to selecting columns. Remember, we have 9 variables here, or 9 columns. I know. Let me just make it straight. Anytime you hear me say variables, just not talking about column. And when you hear me say observations, not talking about rows. So because in research, what they understand is variables and observations. This column and rows is more like a technical part, or let's say more of a computer algorithm or computer word. So in terms of research, it's either it's just best to use variables and observations, which is best. Okay. So now we want to just select two. We want to select 2 variables, which is 2 columns. And then they said, let us select just insomnia and smoke 100 people that's the smoke variable. Those people are smokers and those that are not smokers, which is what is made up in this particular smoke 100. So we just want to select 2 particular column, insomnia and smoke N100. We don't need the remaining 7. So for us to select just those 2, we apply the select function. So select function is used to select columns. Always remember to put your data, because as I said before, it's not just one data that is there, there are 2 data, and you can have more than 2 or 3 or 4, depending on when you want to start running complex analysis. So always remember to put your data first, and then comma. After you comma, you can now say, okay, call the remaining variables you want to select. So you want to call the insomnia variable and then the smoke variable. And then after calling it, you want to assign it. Remember this assignment operator, you want to now assign it to a particular object called select data, just for you to understand that you have selected this particular data. So it's always good to use objects to have a better and easy understanding. It's always good to have an object when you are, but it's always good to have unnecessary objects. Just have objects for better understanding and for reproducible research or projects. So let's assign this. So now you see, It's no more 9, it's now 2 because selected 2. So if we click on this selected data now, you can now see we have only insomnia and smoke. So now we don't want to work with the remaining 7, we just want to work with these 2. Fine. So now we now see some data manipulation functions happening in real life. Okay, so going to the next one, let us create a contingency table. A contingency table for those people that are good with research and statistics. I think for you to actually run a chi-square test, you need to create a contingency table, tabulate your data first of all, and we use chi-square for understanding relationship between 2 categorical variables. Yeah. So now I'll introduce you to a new syntax in R called the pipe. We call this the pipe or the piping syntax. So this piping, so people might choose, let me write percentage and then greater than and then percentage. Fine for beginners, but it's always advisable to be swift with your code. So there is a particular keyboard shortcut we use for that, which is Control